Large cities and cancer share an unexpected similarity, researchers find. City planners are not doctors. They don't have to consider how cancer grows and spreads to do their job, but perhaps they should. A new study suggests that large cities like London and Sydney grow oddly similarity to malignant tumors. Researchers argue that the same key factors that govern the growth of cancer also seems to govern the spread of urban spaces. How did they come up with this? The team, led by urban climate scientist Isabella Capel-Timms at University College London, UCL, says understanding that similarity could help us build better cities for the future. Over the past 180 years, mathematical models show the British capital has rapidly swelled in size to become the sprawling metropolis we know today. The original city of London that existed during the Middle Ages is known as the Square Mile. All of modern London is now more than 600 times the size of that historical nucleus. Well, we know the Middle Ages, there was a lot less population in the world. Now, to reach such enormous proportions, the capital grew like cancer. Between 1831 and 2011, mathematical models show that before the advent of the city's railway network, London's population was clustered in small central area. Long distance travel to the fringes was expensive and difficult. The use of trains, however, permitted the shift to suburban living, allowing residents to live further and further out from the center. This seems to be a trend in other cities worldwide. People tend to like living in lower density areas if transportation to the central area is available. Such dynamics, the international team of researchers argue, are comparative to how blood vessels in cancerous tumors sprout and split, forging new roads into emerging tissue. This process, called angiogenesis, allows cancer to grow more than just a few millimeters in size. The blood vessels deliver oxygen and nutrients to cells further than diffusion could. The same principle appears to hold true for many major cities around the world, such as London, Washington, D.C., Paris, and Sydney, and for different public transport systems other than trains. When scientists at UCL teamed up with researchers at University of Sydney, they found that the Australian harbour city grew in a similar way to London, using data from 1851 to 2011. Sydney's rail system and its urban population evolved side by side in models. Like London, the two biggest factors that seemed to govern the Australian city's growth were the mass of its population and its interconnectedness. These are the same factors that govern the growth of cancerous tissue. Today, the world is experiencing accelerated urbanization and digitalization. The authors of the study explain where cities are generally treated as large machines or logistic systems that can be controlled by top-down inventions. But in reality, they argue, cities behave like complex adaptive systems which evolve to a certain extent like living organisms. This is not a new analogy. Architects and scientists have made the comparison before, but the new study does provide quantitative comparisons between urban and biological growth that could prove useful. The team hopes that city planners will look to the field of biology for future solutions. For example, they suggest policies aimed at regulating the development of road, metro, and railway networks may constrain future urban growth patterns in a similar manner as strategies aimed at controlling vascularization and cell-to-cell interactions can mitigate cancer growth. The study was published in the Journal of the Royal Society Interface. This is by Carly Casella on Science Alert. Please leave your comments and thank you for your support. Kindly support my Patreon account. The daily posts are 5 videos daily, and they are totally different from what I have on my YouTube channel. Thank you so much for your support and that you find all my content so interesting. You'll find the Patreon account details in the description box below.